once you're signed in, guys, go to Google Classroom. You'll see both in the stream here and in the class work tab, okay, that there is a new assignment, Graphing Lab, Position versus Time. If you click on that, okay, you will see the following things. You'll see a PDF document. That's what I'll be working out of. It's the instructions, basically the lab sheet. Okay, there's some data here. You're not going to need that unless you're watching this because you're stuck at home today. Okay, so if you're here actually collecting data, this file is going to be meaningless to you. Okay, and then there's the file you need to work out of your Google Doc. That is what you are submitting to me as your lab report. Okay, that file and only that file will be accepted. Okay, don't go and make your own thing on your computer at home. Okay, I've already built the template. I'm saving you work. All you have to do is fill it in. Okay, the other part of it is, well, that's my file, so I can see what goes on in it, and that's an important part of it. Okay, so all of your work needs to be done in that file. Okay, and that's the one you submit to me. Okay, is everybody clear on that?
Yes, sir.
All right, so the way this lab is going to work, okay, we are simply going to make 2 trials of a cart moving at a nearly constant velocity. Okay, I mean, it's essentially impossible to make something travel at a perfectly constant velocity. So we're going to do our best. Okay, we're going to run our cart twice, get 2 runs, build the graph, a position versus time graph of that data. Okay, perform the analysis, do the lab write-up. Okay, you'll probably get the majority of this done in class today because it's not terribly taxing. All right, so first thing, in your lab report, okay, the expectations are that you give me a problem, okay, stated in your own words in the form of a question. Okay, so this one here says, how can the speeds of 2 different toy carts be determined? Okay, I would say, something about using a position time graph to determine velocity. That can be your problem. That's what we're doing here. Okay, we're examining how we can use a position versus time graph to get the velocity of the cart. Okay, so something in your own words about that will do for the problem. For our design, the expectations in the design part of your lab report are that you will identify and explain each of your variables. Okay, so you'll identify the manipulated variable and explain how and why it's being manipulated. The responding variable, or variables in some cases, not today, okay, how they're responding and why. And then 3 controlled variables, okay, how they're being controlled and why they're being controlled. The why is basically, this is how they'd affect the experiment if we didn't control it. All right, is everybody clear on that? Now I'm going to give you a little bit of help today on that because it's your first one for me. All right, in this experiment, and in the experiment, when we make a graph, which variable goes on the x-axis? Manipulated or responding? On the x-axis? Manipulated. Okay? What you're always trying to find with a graph is the effect of your manipulation on your responding. Okay? So you're looking at what the responding does as you change the manipulated variable. Okay? Now this always gives people like weird feelings, but time, when it's a variable, is always the manipulated variable. Okay? And I know that seems weird because people are like, well, I can't manipulate time. I can't go back in time or forward in time. I'm not saying you're manipulating time. Okay? A manipulation can be as simple as, I determine the length of this experiment to be 2 seconds. In that way, you have essentially set a limit on how far your cart can go. That's how you manipulated time. You said the experiment can only run for 2 seconds. That's your manipulation. Okay? So did I kind of just give you both the identification and explanation for the manipulated variable there? I kind of did. Okay? And I kind of told you the responding variable at the same time. Okay? Whatever goes on the y-axis is the responding variable. In your explanation, basically you just need to tell me what's happening to the position of the cart as time goes by. Okay? And think about the fact that in this case the cart's traveling at a constant velocity. Okay? So you can be specific. Right? Okay, I'm going to give you one of the controlled variables, and then I'm going to tell you how you can use that to figure out 2 more. Right? The velocity of the cart is a control variable. We need it to be constant throughout the lab. Okay, you can kind of figure out why. If we're doing a lab of trying to calculate the velocity of the cart, it would be important that it doesn't change. Okay, we need the position to change at a uniform rate. Okay. If it's important for the cart's velocity to stay constant, anything that could affect the cart's velocity will need to be controlled. So you can think about that for your other two control variables. Okay? Anything else that could affect the speed of this cart over the 2 seconds we're going to time it, okay, needs to be controlled. Explain how you're going to control it and why. Okay, and you may not know that yet. Sometimes you have to kind of look at how this experiment is going to work before you can go, oh, that's something else. Okay, that's fine. You don't need to have it right now. Okay, for our hypothesis, what 3 words go in every hypothesis? If and then. If this relationship exists between these things, or if this is the cause of this, okay, so the if part is the premise, okay, and describes the experiment briefly. In this case, a cart traveling at a constant velocity has its position and time recorded and graphed. Okay, then, in this case, how are you going to calculate the velocity from the graph? Okay, so the if part, okay, the if part should probably talk about what it means to travel at a constant velocity. Okay, basically you're kind of defining what a constant velocity is or it looks like in the if part. Okay. The and part I kind of already gave you, just briefly describe the experiment. The cart traveling at a constant velocity has its position and time recorded and graphed, okay, something like that. Okay. Then, how will you calculate the velocity from the position versus time graph? And we did that yesterday, okay, on a couple of graphs. It may not even really require you to do a lot of calculating. It may actually be right there. So you could even tell me what part of the graph would represent the velocity. That could also be a way to answer the then part. Okay. All right, questions there so far? So, the way this lab is going to work is, you're going to take one of these carts. Okay? Now, when you take them out of the box, be careful. There's a little button on the top, and it often startles people, and then they almost drop or do drop the carts. These carts are over $600 each, so dropping them, bad. Okay? So, just be mindful, if you accidentally press this button, okay, well I have my finger in the way, but this is what usually startles people. Okay? Because they don't expect it. Hits them in the hand, and they drop the cart, and I freak out, and yeah, okay, so we don't want that, just be careful with it, right? On the cart, there's a little graphic here near the top that shows X, Y, and Z. This can actually record data in 3 dimensions, okay? We're only worried about the X dimension, okay? This is the front of the cart, okay? So the part that's got this big black bar on it, okay? That's the front of the cart. Make sure your cart travels that direction. Okay, because the cart and the app define that direction as positive. If you run the cart the other way, your graph is going to go backwards, right? Which I mean isn't a big deal in the end, but it looks wrong. Okay, we want it to go forwards, so make sure it's going that way. All All right, so you'll need to turn your cart on. Power switch is this little button right here underneath the power symbol. Okay, turn it on, and then open up the SparkView app on your phone. All right, so I've still got my data on there from this morning when I tried it out myself. It ended up looking like that. Okay, so when you open it up, you'll want to start a new experiment. Okay, and you don't want to, if you had anything there, it'll ask if you want to save changes. The answer is no. Okay, you'll see this screen has 3 options. You're going to pick the middle one, which is sensor data. All right, and then it'll give you this screen, and there'll be a little Bluetooth symbol. Sometimes it slides over like it did for me, and sometimes it doesn't. Sometimes you have to press the little Bluetooth symbol, and it'll slide over. And it'll list all the carts that are currently turned on in the room. You need to match that up with the number on your cart next to the Bluetooth symbol, because they're each a different one, okay? And this really works poorly when you connect to the wrong cart, okay? Somebody's like doing this, moving it around, and your graph's going all over the place, and you're like, what's going on, okay? Make sure you match up with the right one, because it'll only talk to one phone, okay? More than one group cannot be connected, or one person can be connected to the same cart, okay? So you'll get that, okay? Once you are connected, okay, so right now it's connecting, okay, it'll give you these options. It'll ask you to check the boxes of all the things you want recorded, which is dumb because it records them all anyway. Okay, I don't know why it asks you which ones, okay, but it records them all. Okay, I just click position, and then that's the only one that'll show up on your graph. So it gives you these boxes here, you hit graph, and now it's ready to go. There's a little green button here at the bottom. That starts the recording. Okay, so all we have to do for this experiment is set the cart on the floor. We're not even going to use the tracks. I did this with the tracks and without the tracks. We don't need the tracks. Okay, so just set the cart on the floor. Make sure that it's not moving, which is a bit difficult because not all parts of the floor are level. Possible source of error. You're welcome. Okay. So once you're ready to go, this is where it's much easier with 2 people. For me, I had to kind of give it a gentle little nudge with my foot and then start recording. Okay, but since you're in a group, you'll have someone who can give the cart a little push. Okay, your first trial, you just want to get it moving. So just give it a light push, hit record. There's a little bit of a delay. As long as you get 2 seconds of good data, that's all you need. Okay, you can see it keeps going. Okay, it's starting to slow down, and you'll see your graph start to curve at the end. That's fine. We'll cut that data off. We only need 2 seconds worth of constant velocity data. Okay, so that's your first try. All right, so if I do that again, okay, I'll just give it a little nudge again. Start recording. Okay. All right, so I've got my data there for my first trial, and it's nice and straight. Okay, I got a pretty straight line there. Now, granted, I stopped it before it started decelerating, but that's okay. Again, we can modify, we can cut stuff off that we don't need. All right? For your second trial, you're going to do exactly the same thing. You're going to press that green button again, it'll run a second set of data, okay, on here. This time, give it a bit bigger push. Okay? But don't start timing it until you can see that the push is done. Otherwise, you're going to get like a curve at the bottom and a curve at the top, and we just want the straight stuff. Okay? Everyone kind of with me there? All right, once you've got the 2 sets of data, then we'll talk about how you share it, because I'm going to overload you if I keep talking. Okay, so for right now, we just want to collect the data. So please be careful with the carts. Okay, they are delicate. Okay, okay, so get into groups, let's get data, then I'll talk about how you share it. Okay?
You're terrible.
If you want, please. Want to be in a
No. They're gonna be correct, and I'm not listening to you. Yeah. Yeah, Kira. Okay. And I do that little. And mine?
Ellen, you want to go on that side? When do I catch you? Wait, and then okay, got it.
You got it perfect. Okay, try again.
We can always just get rid of that.
Your velocity graph. Hey guys, let me know if you're having trouble with anything there.
Send it back, Alex.
Oh, okay, we're getting some.
Yeah, there's a delay, right? Like there's a pretty significant delay. So tell them to push. Yeah, give it a little lead. It's easier to just start a new experiment. Oh, nice. Yes. So tell them like start and go push, and then the delay will just keep pushing it. You'll just get there.
Okay, that one was.
A little faster, yeah.
So that was our first one.
Okay.
I don't know why our second one was and then that was our third one.
Okay, so go with the green one and the purple one. So take run 3 and run 1. I'll show you how to do that. Or sorry, run 2. Run 2.
So that would be our first one now.
Yeah. Nope. They only have 2.
Okay, that one was great too.
Okay, perfect. So you got 2 different slopes and beat multiple of them. That's all you need.
Turning part off.
What's that?
Oh, wait, but Mr. Coder, we didn't get 2 seconds of data.
How many seconds did you get?
Like, 1
Did that work?
and a quarter and then 1 and a half.
Okay, we'll cut it back to 1 and a quarter then. This one? It'd be better if we had 2. I mean, it doesn't,
We can redo it.
doesn't take long.
Yeah, it's just pretty good.
Let's just- okay. We need like more in order to get 2 seconds of data.
You got 2 seconds. Just turn it off. Just too disruptive. Okay? No?
My bad.
We have a straight line and then
But how long is it? That's not 6
it's
seconds.
3.5.
It is?
Almost 4. Okay, hold on. Now you need a fast and a straight fast. Straight. Alex, back up a bit. We're pushing faster. Mark? Is that?
Okay, go again.
Super light push, so it's barely rolling, and then one where it's rolling.
Okay.
You go too fast.
Okay, really light.
Oh, you gotta give us 2 seconds now.
That wasn't.
No.
I'm trying to like time it on my phone.
Just like let it roll until I
Let her,
tell you.
unless it's gonna hit something, let her tell you when to time it. Because she can see, right?
Okay, I'll push it. That was way too fast. But can we do a first one fast and a second one?
That's, it doesn't matter what.
As long as they're not the same seat.
Now, literally, give it a little nudge. Oh. Ready?
Good. So these are actually exactly cool.
That's exactly how chili is.
Do we start a second run or do we keep on the same run?
If you press record again, it'll start a second one for you.
Oh, okay.
Oh, that was
Seriously? Yeah.
okay, I'm just gonna let it start.
Put it in box speaker.
Alright, I don't know that you're gonna get 2 seconds on data and that's short distance. You might need to go a little more.
Dude, that's so much space.
Hopefully it doesn't take as much. Or you can try across the front of it because that space is free.
Oh, it just started off.
Okay. So gentle push the first time.
So let me push it. Let me push it.
That was super coordinated. And as the roll, I can't skid.
I thought mine was good.
Back up a little bit.
Yes, please. Make sure they're turned off.
Okay, ready?
A gentle push.
A gentle push.
Okay, come up front. There's less obstacles up here.
It's like completely. I can't. You just got first.
Danny, I did this by myself with my foot. I didn't manage to hit anything. Gentle.
Don't throw it sideways again. I will.
Yeah.
Okay, sure.
I'm not sure. Like for the top, like
Okay.
Perfect.
Yay!
You get 2 seconds? Oh, perfect.
Okay, and then we gotta do another one.
Now do one a little tiny bit faster.
Can I push it this way? Maybe I'll push it in a straight line. But don't we have to do it one way? Yeah. I just
She's
flipped
got the
it.
front of the card facing. It's all good. The card only knows no. Oh, she wasn't ready to do it.
Oh.
But it's a good practice for her.
We can just play toy cards. Do I push it harder this time? Yeah, do I just a little harder but not into the wall? Okay, ready? Yeah, let it go. Did you get 2 seconds?
No, I got one. Is it actually?
Yeah, there's a delay, so you gotta say like, start it, push, then you won't miss this switch.
Do you want ours?
Like,
Or do you want
so you might be living here for time. Okay, so listen up here, guys. The stuff to do with how to share that data, okay? So how you share that data is, okay, in the SparkView app, at the top on the right, there are 4 buttons. One of those buttons is kind of like a triangle with 3 dots. That's the share button, yeah, okay? So hit the share button, okay, and you're gonna go share data, so 3rd button from the top, right? And then it gives you options. You wanna send it by email to each member of your group's school email address, okay? So that like your 2 initials and your student number at Isidore, okay? So send that to everybody, okay, in your group, in the to field, okay, and then everyone will get a CSV, or comma separated value file, okay, which I will show you how to use in a couple of minutes. Okay, so let's get everybody's data sent, and then I'll show you how to get it into Google Sheets and make a graph with it.
Everything, just don't look at the velocity.
Let's try to see it. What?
I don't know. Which was fine. Don't need to worry about that. I can do it
Yeah. 45, 50.
Oh, actually, replans on Holocaust. Send it. Whip it out. That's pretty good.
All right, once the file has been emailed to everybody, obviously then you go to your school email, okay? And I can see that I've sent my data to myself, okay? So if I open that up, I'm going to see, okay, this here, exported data, okay, .csv, all right? I want to add that to my drive. Okay, and then it'll say organized, so you gotta make sure it went to the right place. Okay, so I would say like classroom, okay, and then, oh, there's way too many limits. Okay, so for me, I'm just gonna put it somewhere I can find it, which would be like in a new folder or something. All right, so now that I've got that saved to my drive somewhere where I can find it, okay, I'm going to go to my Google Drive. Okay, and I can see it right here because I exported it just now. Cool. Okay. All right, so I'm going to click on that, double click on that, and it's going to give me the option here to open with Google Sheets, which is definitely what I want to do. Okay, it'll take it a minute to convert it from a comma separated value file to a Google Sheet file. All right, when it does that, it looks like this, which is terrible. But that's okay. We're going to delete a whole bunch of this stuff. That cart records everything you could think of, and we only need the position and the time. Okay? So, if you had one run, or actually hopefully both your runs were more than 2 seconds, but you need 2 seconds worth of time. So the first thing I'm going to do is delete all of the columns that are not time or position. Okay, so I just do that by clicking Control, holding it down, and just highlighting all the things that aren't position. So there was a position when I want to keep that. Ah, shoot. Well, I clicked out without the control key. Pressed down, I lost all of the things I had highlighted.
Yeah, so there's two questions. So how do you do this?
Okay, so when I get to this point here, and guys, it's okay if you're not keeping up with me. I'm recording this, and I also have a shorter version of this also attached in Google Classroom. Okay, so you can see what I'm doing. Once I've deleted all of those things that I don't need, okay, I need to look at which one of my times is best. They both go for more than 2 seconds, so I'm just going to delete the second one. Okay, so I'm left with the time, the position for my first run, and the position for my second run, because that's all I need. Okay. Then I'm going to click in the first box, click and drag, and highlight everything. All right. And then I'm going to go to Insert. And I'm going to go to Chart. And I'll get this. Okay? Now, this graph is way more than I need to keep. All right? I only need 2 seconds worth of data, and you can actually see that both of my lines start to flatten because the object starts to slow down after about 2.5 seconds. Right? Since I only need the good data, I'm going to delete everything after 2 seconds. You may have to delete different things depending on what your data looks like. You might have to delete some stuff at the beginning. You might have to delete some stuff at the end. That's up to you. Okay? You have to decide what parts of your graph you need to keep for this lab, which is just the diagonal part. Okay? So what I do now that I've got that chart, okay, I'll obviously want to fix some things like the title, get a label on each axis, okay, stuff like that. That's all done in the Customize tab. Okay, under chart axis and titles. Okay, like obviously position run 1, position run 2 is not a good title, so you could call it like graphing lab or something. Okay, and maybe write like position versus time. Okay, and then I also need to make sure that I have a vertical axis label. Position is on my vertical axis. It's in meters. Okay. All right, so now my graph looks right. Okay, there's a couple of things I want to add to my graph before I edit off the points. Okay, and that is that I want to get a trend line. So if I go into series, okay, the drop-down menu for series, right? Hopefully this says apply to all series. That's the default for Google Sheets. Okay, you can change the size of the dots if you want. Okay, it makes them not overlap if you do. And then I want a trend line, so I just check this box. All right. Now I want it to be linear, okay, which is what it's drawn. You can make the thickness of the line bigger if you want, so it's easier to see, or you can make it more opaque, okay, if that helps, but it doesn't really matter. Then, in the label field, right now it says none. Click on that, and have it show the equation for the line. Okay, by clicking on that, you'll get y equals m times x plus b for both lines. Right, so you can see that's up here now. For my blue line, y equals 0.22 times x plus 0.109. For my red line, it's y equals 0.356 times x plus 1.08. Okay, so I've got the lines, okay, I've got the equations for each line. That's it. That's all I have to do. Right, so now I can just copy that chart into my Google Doc. Right, so right down here where it says insert your data, charts, and graphs. I'll link it. Boom, it's in there.
Wait, weren't you supposed to delete the dots?
Oh, it's linked, so it's going to delete it. It'll delete it in both because I linked it. Okay, so if I go back Okay, now that I'm looking at this and realize that, gee, I don't need all this data here past 2 seconds. So I'm just gonna click here, highlight it all, and I'm gonna delete cells and shift up. It's really important that you say shift up when you do that. Okay? It changes my graph here. Those flat parts are gone. My graph only goes to 2 seconds. And if I go back to my Google Doc, the graph is also changed in my Google Doc. Okay? Actually, sorry, it hasn't changed yet, but it'll say, it'll update right here. Now it's changed. And you'll see it changes my equations a little bit too, and that's fine. Okay, so that's how you get the graph. All right, and I can help anyone with that if they're struggling with it. And I have a 7-minute version of what I just did posted with the assignment if you're doing it at home and you get lost. Okay, you can follow it, pause it, okay, and it'll work. All right, so in there you've got your graph. You should also have your chart. That would be this stuff here. So copy and paste that as well, just for 2 seconds. So copy it, paste it in as well. Okay, so your data is there, and your graph is there. Okay, for the analysis, just follow the instructions. Okay, you've done most of it already. You've got the graph. Okay, so using that spreadsheet, determine the velocity of both cars. So basically what I'm going to want to see is, how did you get the velocity from this equation? Okay, you don't have to plug in any more numbers. Just tell me this part of the equation represents the velocity. Here it is in meters per second. Okay. For the conclusion, copy paste your hypothesis and then give me an explanation as to why you can accept it or reject it. Did your graph look the way you predicted? Were you able to get the speed, or sorry, the velocity the way you predicted? Okay. And then for your evaluation, 2 sources of error. I gave you one. Okay, 2 sources of error and how you could fix them in the future. No, do.
You don't fix them.
You do fix them. How would you fix them?
If you lived in a perfect world.
That's
you
okay.
fix them.
You could, or you could not use this piece of floor that's, you know, like this. Okay? You could find a flatter piece of floor. Okay? Or a track that's flat or something. Okay? So that's what we're looking for. Does that make sense to everybody?
Yes, sir.
All right. You have the rest of the class to look on. If you need some help, let me know.